Yep.
Please have a seat.
Yep.
Welcome to our question and answer session. Since we launched our hydrogen solution, we have received a lot of questions from the market. And today we will try to answer them all. My name is Markus, I'm CEO at MannTek, and I have a good help besides me.
My name is Gerhard Kopplin and I'm the technical director at MannTek.
Yeah. If you look into the questions, there's some quite general ones. And the first one is what is the idea behind hydrogen, liquefied hydrogen in our solutions? And to liquefied hydrogen is it's all about reducing the volume so you can transport more energy. 1 liter of liquefied hydrogen becomes 1,000 liters of gas. This means it's a perfect fuel for heavy vehicles such as trucks, buses, trains, but also as a ship fuel, and maybe also for the aviation industries. It also enables you to transport huge volume of energy. So this means you don't need to connect the producer of hydrogen with the consumer of hydrogen. You simply liquefy it at the production plant and transport it as a liquid on a truck, on a ship or a rail tanker, and then you liquefy it at where it should be consumed. This concept is called also virtual pipeline. Simply, you don't need to have a rigid pipework between the producer and the consumer. Of course, in many cases, this means that you need to offload and load again from the production plant into the ship, from the ship to the truck, from the truck to the end user. And at all these on and offloading points, you need to transfer it from one tank to another, and this is where we have developed our equipment. So, how does it work? Gerhard, please help me.
Yeah, the principle, the idea behind that, it's quite simple. We're using a coupling which is known from the hydrogen handling, which is vacuum insulated, and we integrate some valves and combine it with the connection principle, what we have known from our chemical couplings. So that makes that we have much smaller space, which we have to get out the air. We don't need to purge the complete hose. It's sufficient that we purge only the space between the couplings.
Purging, I believe I understand, but what's that?
Purging means at least we have some air which will become liquid or ice when it's cooling down. And to get out this air from the process line, that's the meaning with purging.
Mm-hmm. And how far did you come in the development of the hydrogen solutions? When I walk by your office, you seem quite ready. Is it like that?
Yes, we have products out in the field. We are testing them right now. And that is for truck fueling applications, but also for ship bunkering.
Okay, then we move in a little bit into political questions. How you solve the legal frameworks and concerned regulations. Our equipment is quite new, and I can't believe the regulations is still under construction. Or could you talk us through it?
Yes, there are different levels. On the European directive level, there are guidelines available today about alternative fuels. They are also handling or take care about liquid hydrogen as a new fuel or energy source. On the next level, where we have the regulations, the technical specifications, there we have still some work to do. At the moment, there are building up some international standardization committees. I'm also a member in them. And we try to find a common view about fueling procedures and also find maybe a common interface, the geometry and the technical specification for that.
Okay, so when the politicians are ready, we are?
Yes, we are.
Okay, Fantastic. Another question is here, if how we look on that, if the hydrogen will have an important place in the future energy infrastructure. Yes, of course, it will play a big role, and there will be a mixture of different things. We have battery is one side with its limitation and environmental impact, but for hydrogen, why not?
Yeah, there are in these European guidelines a lot of alternative energy forms specified. Hydrogen is one of them, and many of these new fuels have still their own challenges which have to be solved, and everything is specific for each application. So batteries, they need to be sustainable as well in the future. You have metals which need some resources which may be limited as well. And so hydrogen has its own challenges as well, yes.
Yeah, one of the questions is, how about ammonia? Is it still, it's also something that we are trying now, or do you know anything about the status?
Ammonia, it's also in consideration for transport over longer distances. We have experience with ammonia since a long time as well. So there is nothing for us to develop. That's why we're focusing on hydrogen.
We already deliver equipment for ammonia handling.
Yeah.
The advantages of using hydrogen, yeah, of course, what everybody says, zero emission. Is it something more?
Yes, you have very low storage volume when you liquefy it. The virtual pipeline, zero emission, it's compared to, let's say, ammonia, you will always have something, some kind of emission. The idea behind hydrogen is what you generate as emission is pure water.
Pure water. Sounds great.
Yeah.
When do you think hydrogen will be a significant part of the fuel and energy infrastructure? Of course, right now I don't believe there is a huge amount of green hydrogen produced in the world. There is concepts, but I don't see any capacity right now. But what will happen?
Yeah, the infrastructure needs to be built up, but before we can do that, we need to show and demonstrate that the principle is working. That's why we developed the couplings to close this gap. And I think maybe 2030, there will be so many projects running that we can say we have some kind of infrastructure available, that it's available in a bigger picture, let's say. I estimate that will be till 2050 maybe.
Yeah. The discussions with, for instance, the truck manufacturer, the bigger ones, they are launching, it seems that they will be produce a little bit more than prototypes already in 2025, 27. How about that? Yeah.
Yes, they are going on the road now with field test trucks, and the target is that starting with serial production somewhere around 2025 to 2027. And yeah, if this will be successful, I think there will be more following on that road as well.
From the inquiry we have, they're asking which application the coupling is suitable for. For us, it has been right now test with aeroplanes, it has been space rockets, trucks and so on. But yeah, is there any specific demand in these different fields? If we start with the aviation industry, how do they differ in demand compared to, for instance, the truck refueling?
Yeah, the aviation industry has a lot of own rules and challenges. They are very focused on flight safety, lightweight, so you need to have a certain number of redundancy in the systems. And yeah, lightweight, they don't want to carry much weight, which consumes even more fuel in that case. And I think liquid hydrogen can solve this.
And if we discuss the marine sector, I mean, weight is not that important anymore. What are the challenges there?
Yeah, marine application, the challenges for us is it is less harmonized. So you have a lot of different classification society which are on the way to develop their own rules. So at the moment, for us, the challenge is because they don't have existing guidelines for liquid hydrogen handling, we have to go from the beginning with all the classification societies and find a way how to approve the products.
If we discuss then trucks, I mean, trucks is a lot of manufacturer, and I have a feeling they need to agree on a common interface or something like that before it's a hen and egg effect always when talking about hydrogen. But how do you feel that, or is there any groups that working together, or?
Yes, we have a working group where we try to find some kind of standard connection. The truck fueling industry or application is for us a little bit different today because we are typically in the industrial area. We have trained people using our products, and now we need to think a little bit different. So it will be the end user in unprotected areas, which also put a special demand on the solutions.
Yeah, up till today, it has been professional people that have made the handling of the hydrogen, and in future all the truck drivers need to do it by themselves.
Yeah, that's right.
Technical challenges, how do you see it? I mean, still at this stage we have something, but describe a little bit.
In general, that what we had to consider when we were making the development was it is extremely cold. We are down to minus 250 degrees. And at that temperature, air will condensate on the outside of uninsulated pipelines. So we have to think about insulation concepts, which we did, which we solved, yes. We need to integrate it into a hose system because connecting a lot of vacuum insulated components will make the system long and stiff, and that's something what is not nice to handle.
If it's not completely clear for the audience, that you will have a condensating air on outside the pipe or the couplings, what is the problem with that?
The problem is that you have enriched atmosphere of oxygen. That means the concentration of oxygen is increasing and oxygen is reacting with more or less everything. So the risk for burning, exploding may become much bigger, or burning mainly. And that's what we want to avoid, that oxygen will condensate on the outside.
Yeah, so safety besides everything, but keep the outside temperature above the condensation point of oxygen is very essential.
That's correct.
When we are talking about risk and people ask, is it dangerous? Yeah, everything is dangerous. I could imagine if you should ask, if petrol didn't exist as a fuel and you should ask for a permission to transport it, I don't believe it have a go from the authorities. But how about hydrogen? How do you see danger and risk management?
All our products are produced and invented to handle so-called dangerous goods, and dangerous goods is a very wide range. So for us, we are used to think in risk management and risk assessments. And risk is only available if you don't know what you're doing. So as long as you have the solution, you're aware about all potential risk, and you handle it through the design or through description how to use it, so training of people, then it's no risk anymore. It's safe.
It's safe. But with the existing or the equipment used up till today, then it has been a huge demand of the operator to not make mistakes. With the couplings, I could imagine it's failure proof, so to say.
Yeah, we have discussed a lot with our partners to find solutions. Finally, we did it as well. They have the experience since many, many years, much longer than we. They are working with liquid hydrogen, and yeah, we could learn from their experience. And that's what we try to implement into the products as well.
Yeah, and maybe it's perfect. Now I have some question about the function of the coupling. Could you please demonstrate?
Yeah.
Is this the right one?
Yeah, that's the right one.
Yeah.
So this is a coupling for truck fueling. We have the connection part. We have a locking device here that when we make the connection, that we lock it first before we open it. So the function between connection and opening is separated.
Yeah.
And that was the point that we are able to make an automated version out of this later on. And this later on has already happened.
Yeah, so. But first you connect it to the vehicle.
Yeah.
And you make a proper connection, and then you maneuver the coupling again.
Yeah, we unlock it here. Yeah. We turn it back, and then we come into a purge position.
Yeah. Why purging?
The purge position means that we take out the air which is locked between the male and the female parts of the receptacle and the nozzle.
And with the older design, you need to purge the complete line, the hose and the coupling and everything.
Yes, there were open systems without integrated valves, and this is what we finally did. We integrate valves, which are only opening when we make the connection.
Yeah, and now you are only purging the distance between the hose and tank unit.
Takes much less time, yes.
Good. But still, I see there is some locking device and turning and so on. It's, I mean, it's safe, I understand, safer, but still you need to have a trained operator.
Yeah, you cannot do it in a wrong way, but yeah, it's sensitive for, let's say, misuse. If somebody wants to destroy it, it's more easy to do that when he has the possibility to operate more things. He has to do it manually. So if you don't understand how the coupling works and he's impatient, he can destroy a lot on the coupling.
Yeah, and the next one with a lot of electric wiring and pipes.
Yeah,
right.
That's the solution to make it even more safe.
Okay.
Yep.
I don't know what's upside down on this one.
Looks more or less quite similar. So the front part is the same. You also make the connection, but instead of that you are operating the locking functions and so on manually, you only make the connection, and then you have automated function for locking, for the purging, for the complete fueling process.
Yeah, and all this is controlled by the dispenser.
That is all controlled on the dispenser side, yes.
So this one could be handled by the truck driver in the future.
Yeah, that's the idea.
Fantastic. The next question here is, how did we cope with extremely low temperatures? I mean, in the past, we looked at ceiling. The ceiling itself needs to stand the cold temperature or the media, the aggressivity of the media. But here, I believe it's even more challenging.
Yeah, the temperature are even lower. So we need to seal at minus 250 degree. So it's on one side challenge for the material, and to avoid that, that we only rely on the material in contact with the liquid, we place a second backup seal a little bit more far away from the liquid, and this is not as cold as the main seal. So that then you can use sealings in rubber, which has much better performance when it's warm.
Yeah, but it's more or less impossible to have a material that by itself will withstand this. You have a combination of two seals.
Yeah, that's the idea.
The last one, what is required for you to be able to start production of the couplings for hydrogen? What in a large scale? I mean, for us, we have the solution, but the market and the production is not there yet. Could you say something about that?
Yeah, the industry is looking now for verifying the solution itself, yeah, we need to only demonstrate that it's working in that way, and then we can scale up when the demand is growing. Yes.
Yeah. Simply waiting for the market.
Yeah.
At this stage. Okay.
Yeah.
Have there been any tests of the coupling? I could imagine that.
Yeah, sure. The couplings are used in applications where you need to have certification. So there are third parties involved, and they require that your testing and also the customer don't want to bring a new development into application without testing. So we were going from tests first with liquid nitrogen, what we can do here by ourselves, to demonstrate that it's working, the concept is working at low temperatures. And then you have to go further steps, test it with liquid nitrogen at test laboratories. And later on, then you will go into the field tests, and that's the stage where we are right now.
So here we are able to test down to minus 196 degrees.
Yeah.
First stage, and
then we need to go down to minus 253, and we need to show that hydrogen, which is much more much thinner than nitrogen, that the sealing concept will work also with thinner media.
And all this is done?
All this is done, yes.
Thank you. Okay, I believe this was most of the questions today, and thank you, Gerhard, for answering them all.
Yeah, thank you as well.
Yeah. If you have any further questions, you are free to contact us. Send us an email or simply use LinkedIn. Thank you very much for listening.
Thank you.